Here we have a SAT math question. Okay, let's go to the information. The area of a right triangle is 270 square units. The longest side of the triangle is 39 units. What is the length of the shortest leg? Okay, first let me draw a right triangle. Here I have drawn a right triangle, and in any right triangle, hypotenuse is the longest side and hypotenuse is the side which is opposite to right angle. So this is the hypotenuse, and the question says the longest side of the triangle is 39 units. So which is the length of the hypotenuse? So the length of this side is 39. Okay, now let me assume the length of this leg as x and the length of this leg as y. Okay, now I have to find the lengths of these two legs. I have to find the values of x and y. So once I get the values of x and y, I can know the lengths of these two legs. Then I can now find the length of the shortest leg. Okay, now let's use the information we have in the question. That is, the question says the area of this right triangle is 270 square units. Okay, let me write that is area equals to 270 square units. We know the formula to find area of a triangle, that is base times height divided by 2, so equals to 270. We know that the base is given by this leg, that is x, and the height is given by this leg, that is y. So we can plug in x for b and y for height h. Then I'm getting x times y equals x times y over 2 equals to 270. Okay, now I multiply both sides of this equation by 2 to get the denominator 2 over here. So then when I multiply both sides by 2, this 2 will cancel. I'm getting x times y equals to, when I multiply this 270 by 2, I'm getting 540. So let me assume this is equation number 1. Now I consider a Pythagorean theorem in this right triangle. Pythagorean theorem says sum of the squares of two legs of a right triangle always equals to the square of the hypotenuse. So that is, if I square these two legs and add them, and it must be equal to the square of the hypotenuse, that is 39 square. Let me write over here, that is x square positive y square equals to 39 square. Okay, then I'm getting x square positive y square equals to, when I take square for this 39, I'm getting 1521. Okay, now I'm adding 2xy to both sides of this equation, and I'll tell you the reason a little later. So when I add 2xy to both sides of the equation, then we get the expression on the left side, x square positive 2xy positive y square equals to 1521 positive 2xy. Now let's consider one of the important and basic identities in algebra, that is the square of the binomial a positive b the whole square. Its expansion is a square positive 2ab positive b square. Okay, now let's consider the trinomial over here, a square positive 2ab positive b square. So whenever we have a trinomial in this form, it can be written as a square of a binomial, that is a positive b the whole square. Now consider the trinomial we have over here, x square positive 2xy positive y square. So this is exactly in this form, a square positive 2ab positive b square. So instead of a we have x, instead of b we have y. So for this trinomial we write a positive b the whole square, and for this trinomial what can we write? So we have to write x positive y the whole square. We just have to replace this a by x and b by y. Then I am getting x positive y the whole square for this trinomial. On the right side I am getting 1521 positive. And 2 times for this xy, x times y, I know the value from the first equation, that is 540. So we can plug in this 540 for this xy. Then I'm getting 2 times 540. Then we get x positive y the whole square equals to 1521. When I multiply 2 and 540, I'm getting 1080. So then I'm getting x positive y the whole square. Let me write it, equals to, when I add these two numbers, I'm getting 2601. Okay, now to get the square over here, I'm taking square root on both sides. When I take square root on both sides, the square root and square root cancel out. I'm getting x positive y equals to, when I take square root for this 2601, I'm getting 51. So usually we consider positive or negative sign for one of the square roots when we take square root on both sides of the equation. But here I consider only positive value because both x and y are positive values. Because x and y are the lengths of the two legs of the right triangle, they can never be negative. Okay, now I got x positive y equals to 51. Let me write the same equation over here. Now in this equation, I have to solve either for x or y. Okay, now let me solve for y. For that, I have to subtract x from both sides. When I subtract x from both sides, a positive x, negative x will cancel out. I am getting y equals to 51 negative x. My aim is to find the values of x and y, which represents the two legs of the triangle. So only if I find the length of the two legs over here, I'll be able to get the length of the shortest leg. Okay, now what I have to do is I have to plug in 51 negative x for y into the first equation, so that we'll have this equation in just one variable. Okay, now let me plug in, so y equals to 51 negative x into the first equation. Then I'm getting x times 51 negative x equals to 540. Okay, now let me distribute this x to this 51 and negative x. When I do so, I'm getting 51x negative x square equals to 540. Okay, now let me write negative x square first. Then we have positive 51x equals to 540. Okay, now let me subtract 540 from both sides to get the quadratic equation in standard form. So this positive value, negative value will cancel. I'm getting negative x square, positive 51x, negative 540 equals to 0. Okay, now we have quadratic equation standard form. That is, we have everything on the left side, on the right side we have 0. Okay, to make the leading term as positive, we have to multiply both sides of this equation by negative 1. So here the leading term is negative. So to solve this equation, usually you keep the leading term as positive. So for that, we have to multiply both sides by negative 1. Let me do it. Negative 1 times negative x square, positive 51x, negative 540 equals to negative 1 times 0. So negative 1 times negative x square is just positive x square. Negative 1 times positive 51x, negative 51x. Negative 1 times negative 540 is positive 540 equals to negative 1 times 0 is 0. Okay, now let me take the same equation over here. That is x square negative 51x positive 540 equals to 0. I think this quadratic equation can be solved by factoring. Okay, to solve this quadratic equation by factoring, I have to multiply this constant term positive 540 by the coefficient of x square, that is 1. When I multiply this 1 and positive 540, still I'm getting positive 540. Okay, now I have to get two factors for this positive 540 so that the product of two factors equals to positive 540 and the sum of the two factors equals to the coefficient of x negative 51. I think negative 36 and negative 15 will work. When I multiply the negative 36 and negative 15, I'm getting positive 540. When I add them, I'm getting negative 51, which is a coefficient of x. Now to get the two values of x, I have to divide these two factors by the coefficient of x square, that is 1. Even if I divide these two factors by 1, still I'm getting the same values, negative 36 and negative 15. Okay, now to get the first value of x, I have to change the sign of this factor. Already it's negative 36. If I change the sign, it will become positive 36. So that's the first value of x. And now to get the second value of x, I have to change the sign of the second factor. It's negative. If I change the sign, it will become positive 15. Okay, now I got two values for x. One is 36 and the other one is 15. Okay, now to get the values for y, what I have to do is I have to plug in x equals to 36 and x equals to 15 into this equation. Okay, let me do it. So when I plug in x equals to 36 into this equation, then I'm getting y equals to 51 negative 36. Then I'm getting y equals to 51 negative 36 is going to be 15. Okay, now what I'm going to say, I'm going to plug in the second value of x, that is 15, into the same equation over here. Then I'm getting y equals to 51 negative 15. Then I'm getting y equals to 36. So the lengths of the two legs over here, 36 comma 15 or 15 comma 36. Anyway, so we got the same lengths for the two legs. So like we can consider either the first pair or the second pair. Let me consider first pair, that is x equals to 36 and y is equal to 15. So the lengths of the two legs of the right triangle are 15 and 36. So according to the question, we have to find the length of the shortest leg. So in these two lengths, 15 and 36, so the shortest leg is 15. Therefore, the length of the shortest leg of the given right triangle is 15 units.